The blind spot in AI for engineering and operations. Chapter 1. In the age of AI, the cost of extending platforms with purpose-built intelligence has dropped by an order of magnitude. The calculus has shifted, but only for organizations that understand what AI can and cannot contribute. This chapter introduces how that shift is reshaping the software decision for engineering organizations, and this perspective is grounded in direct experience. ReVisionz works with engineering contractors and owner-operators facing these decisions, and the patterns of what works and what fails are consistent enough to be examined in detail. The cost objection no longer holds. The traditional argument against custom engineering tools was simple. The build cost, integration effort, and ongoing maintenance of a bespoke EDT, EDMS, or tag management system outweighed the pain of adapting to a commercial platform. AI-assisted development has collapsed that logic. Functionality that once required months of specialist effort, including attribute schema configurators, bulk tag validators, document transmittal workflows, and revision control engines, can now be prototyped in days and deployed in weeks. At the same time, the cost of doing nothing compounds. Relying solely on the out-of-the-box platform without encoding your asset-specific rules into it leaves value on the table across every project. Mandatory upgrades, implementation partner fees, and data migrations routinely exceed original total cost of ownership (TCO) calculations, and none of that spend builds proprietary capability you own. The comparison that justified the buy decision was based on day one cost, but the real cost emerges over the life of the project, and it rarely matches the original assumption. Off the shelf alone leaves value on the table. Every major capital project has a tag numbering system, a functional location hierarchy, an equipment class taxonomy, and a document numbering schema that reflects how that asset was designed and how it will be operated. Commercial platforms provide powerful foundations, but they are built for general use. They cannot anticipate every project's specific conventions. Without an intelligent layer that encodes your rules, teams fill the gap with mapping tables, parallel spreadsheets, and ongoing manual workarounds. The opportunity is not to replace the platform, but to extend it. Tags, attributes, parent-child relationships, and document linkages can be governed by AI-assisted logic that sits on top of your existing system, enforcing your specific conventions at the point of entry. The compounding competitive moat. Contractors and owner-operators who build proprietary intelligence on their information platforms gain an advantage that compounds with every project. An AI layer that enforces naming at entry, validates against P&IDs, and auto-populates datasheets becomes a delivery capability competitors can't match, even on the same platform. Each project hardens edge cases, validation logic, and integrations with ERP, CMMS, and document control. Others restart with the same tool. You start with a system that learns. The gap widens. There's also a risk dimension. Vendor lock-in risk. Platform only made sense to avoid building and maintaining custom software. But relying on one platform with no proprietary layer creates concentration risk that grows over time. Platform-certified talent is scarce and expensive. A proprietary intelligence layer reduces that exposure by keeping high-value knowledge in assets you own, not just the vendor ecosystem. AI-assisted development has lowered the resourcing bar for building and maintaining focused tools. Still, custom development isn't right for everything, so it's important to know where the case holds. When platform only still works. Commodity functions. File storage, standard archiving, HR, rarely justify extra development. An AI add-on is most valuable where software touches the asset data model, tags, document coding, and handover/as-builts. If you know the platform's limits, a middle ground exists. A lightweight SME-guided AI layer can improve fit to your data model without disruption, capturing value now while you decide whether deeper investment is warranted. How the three paths compare. Initial cost rarely matters most. Over 5 years, SaaS increases, often 10 to 20% per year. Upgrades, partner fees, and migrations compound. So the cheapest day one option can become the most expensive over the project life. The comparison below shows how each path performs across those dimensions. Dimension: off-the-shelf SaaS EDT/EDMS, SME-guided AI Copilot layer. Platform plus deep custom layer. Day one cost: zero upfront license cost. The traditional justification for buy. Low: a focused Copilot built with AI-assisted tooling can be deployed in weeks. Platform license plus custom layer investment. AI-assisted development has significantly reduced the build cost of the layer. 5-year TCO. Escalating per-seat fees. 10 to 20% annual increases common. Mandatory upgrade projects. Implementation partner dependency and migration costs if the platform changes. Frequently the most expensive path over a project lifecycle. Platform license costs remain. Copilot maintenance is low and controlled internally. Proprietary intelligence stays in-house regardless of vendor pricing decisions. Platform license plus controlled layer maintenance. The custom layer roadmap is yours. No compulsory upgrade cycles or external rate increases on the proprietary component. Data model fit. You restructure your tag register, document coding, and attribute schema to fit the platform's data model. Platform data model unchanged. Copilot applies your rules on top of what the platform stores. Best of both. Platform foundation plus a deep custom layer built precisely around your naming conventions, functional location hierarchy, and document coding schema. Tightest possible fit. AI integration. Vendor-controlled. Generic classification models with no awareness of your asset taxonomy or project context. SME-guided AI operating on your platform's data. Rules, exceptions, and validation logic encoded by your engineers. Platform AI capabilities extended by a custom layer trained on your full data history, tag register, P&ID library, document history, contextually accurate in ways the platform alone cannot be. Vendor dependency. The original rationale for buy was to avoid the resourcing risk of building. That logic has inverted. Companies now struggle to resource platform-specific expertise precisely because the vendor's proprietary code is complex and ever-changing, forcing reliance on premium vendor consulting services at non-negotiable rates. Reduced. Core platform dependency remains, but the highest value intelligence lives in your Copilot, not the vendor. Internal teams can maintain and extend it. Platform dependency remains for core functions. The custom layer is owned internally, so the highest value intelligence is not held hostage to vendor pricing or resourcing decisions. Delivery moat. Every EPC or owner-operator on the same platform has the same capability. Zero differentiation. Moderate moat. Your SME knowledge base becomes a proprietary asset. Competitors cannot replicate your encoded rules. Strongest moat. The platform provides a shared foundation, but the deep custom layer compounds with every project. Competitors on the same platform cannot replicate what you have built on top of it. The pattern that emerges is consistent. The decision isn't simply about cost or speed of deployment. It's about where your organization's knowledge lives and how effectively your tools can encode it. And that distinction is what determines whether your tools remain a constraint or become a source of competitive advantage. The lifecycle doesn't stop at handover. The engineering information model continues into operations, where its value is realized or lost. Owner-operators inherit the contractor's tag register, functional location hierarchy, and document library. If these follow contractor conventions, operations bears the cost. Work orders reference unfindable equipment. Records don't align with as-builts, and CMMS locations don't match field practice. This creates recurring operational cost. Technicians spend time searching for documents and reconciling mismatched tags instead of executing work. Embedding the operator's data model from the start, not only the contractors, improves handover quality. An AI layer can help enforce these conventions so information arrives in an operations-ready structure. Operations and maintenance, the real test. Operations and maintenance extend over the asset lifecycle, typically 20 to 40 years. The engineering information model must support long-term retrieval, change management, and use. Information use differs by function. Engineering produces and structures data, while operations consume it frequently and are time-constrained. Common needs include rapid access to P&IDs, equipment records and maintenance history, along with consistent tags and attributes for reliability analysis over time. Platforms provide storage and access, but do not inherently encode site-specific conventions. For example, tag rules, equipment classes, required attributes. That logic must be defined, governed, and maintained. An AI layer can help apply it consistently from engineering through operations. Organizations that perform well treat engineering and operations information as a single, continuous model, feed through detailed engineering, handover, and sustainment, designed for navigability and maintainability across the full asset life. Where this leads and how ReVisionz can help. The economics have shifted, but shifting economics alone doesn't guarantee better outcomes. There is a more important question underneath all of this, and it's the one most organizations miss when they start exploring AI-assisted engineering tools. AI lowers the cost of building intelligent extensions. It doesn't know what to build. In engineering and operations information management, the gap between what AI can generate and what a production-grade asset data layer actually requires, one that holds its shape from feed through to the end of asset life, is filled entirely by domain expertise. That's what Chapter 2 will explore, and it's where most AI initiatives in this space either compound their advantage or stall. If your organization is weighing these decisions now, ReVisionz can help you work through the specifics. Reach out to our team to start the conversation.